So now, Tim, it's just you and I. What's going on, sir?
What's going on?
Yeah,
Well, it's another beautiful day here in Carlsbad, California, just
there you
north
go.
of San Diego. And that's the good news. The bad news is I'm stuck in this God-forsaken home office like I had been for for over 2 years now, right?
Yeah, yeah.
So, yeah, life goes on. There's good news, there's bad news. It's all good. It's good.
We're starting to get back out there a little bit, though, right? I mean, we're starting to travel a little bit more.
Well, me and you are going to spend some quality time in what is that, next week, 2 weeks?
Yeah,
Yeah,
right?
I'm
We're gonna
excited.
explore.
Honestly, I'm really excited. And Kelly is like ecstatic. That's my wife,
Yeah.
33 years, who you know so well. Yeah, we're flying out to Europe and doing your gig and doing a couple other conferences, some keynotes and
Definitely.
stuff. Yeah, it'll
I
be
can
fun.
tell
Yeah, that just getting outside, and I'm an outdoorsman, and just getting out and away from the stress of the pandemic is just fantastic. So I'm excited.
you. Yeah,
It's an arduous journey to get all the way from where I live to you to live.
for sure, for sure.
You almost could go the other way around the world from where I live on the West Coast.
Almost. Yeah.
Yeah, yeah. But
But it's good to have you guys back over in Europe, and I look so much forward to seeing you and of course your better half very much.
much
So
better half is what most people say.
much better half. Let's go with that. Yeah.
She,
Um,
she's in the background here, and I said, whatever you do over the next hour, please keep your dog under control. Okay, if you.
Totally. All right. Well, so let's get on with it then. The show, as it is, and you're going to talk to us about AI. And I love the title of your talk. It literally very much just sells itself: the ethical dilemma of AI: save humanity or destroy it.
Yeah, I love this talk. I really do. It gets people thinking, and I've got
Yeah.
some cool demos, and it makes many people who are not savvy to this world. It makes them go like, "Oh my goodness."
Yeah.
But at the same time, like, "Holy cow, we're saving lives with this stuff."
Exactly.
That's the point.
It's very cool. And so I'm going to kind of leave you to it because I know you want to spend some time with your talk here and deliver for us. We're so happy to have you. And so I'm going to go away in a second and leave you to do your thing. You have the whole hour, but you can end towards there. Give us 10 minutes to have a conversation
Well,
after or something.
aren't you being polite? You and Rick, my dear friend Rick, and you said, "Tim, you got 45 minutes. If you go over an hour, you're never working in this industry again." Isn't that what
Pretty
you
much.
told me?
Well, much more the case that Learn TV is going to go.
Sure. All right.
You guys are not off. You're free to continue talking after that. No one's going to be watching you.
Fair enough. Fair enough. I got it.
So,
We should be fine. I did.
yeah,
I timed it yesterday and again this morning. We should be fine.
perfect, wonderful. Well, I mean, take it away. The floor is yours,
I
and
think you
I'll
want
see
me
you
to
after.
share my screen, right?
Yes, and then
I'm
um,
sharing.
Rick is going to cue you up and all with fixing
Oh,
up
it's
that
giving
we
me
can see you,
guidance.
and I will go away.
And I want to share. All right, I'll talk to you in a bit, Magnus. Thanks. Good to see you, buddy, even though it's virtual. I assume you're seeing my screen.
Yes.
Awesome. Well, then let's get rolling. Hello and welcome wherever you are. My name's Tim Huckaby. And as Magnus mentioned, this is technology talk, which focuses on the ethics that we have as developers, as technologists, and how much power we have because this world is moving so quickly. So there's my contact info, but you don't need to take screenshots or write it down or anything like that. On the very last slide, I'll have that stuff, and then I'll have a link for you to download, if you want to download this PowerPoint deck. I'm more than willing to give you this PowerPoint deck. There's a ton of links in it to the source code and the demos. And a lot of people use my slides in pitching their own organizations on, we need to do this stuff. So yeah, I've been doing this a long time. It's my honor to be here today, but I am comfortable in front of an audience, although honestly, I'd rather be in front of you in person, but even virtually, I'm comfortable in front of an audience. We're joking about the timing thing. I should come in timing just great, unless I tell Bill Gates stories. Then we may be late. I worked at Microsoft in the late 90s on the Windows NT server group. Believe it or not, that's how old I am. Great years there, and then founded a couple companies after that. So there's young, skinny Tim, top left, and to the right with Steve Ballmer, and then there's old keynote Tim on the bottom. So here's what we're going to talk about today. We're also going to pose some interesting questions that don't have answers as much as they generate opinions and discussion. This is the type of stuff you talk about in a bar, frankly. We'll talk about some of the good things and great things happening as a result of artificial intelligence, and we'll also talk about some of the bad things. We'll talk about how easy it is to develop, or how easy it is to develop solutions in AI and the complications therein with having it so easy to build AI complications. I'll do a lot of my focus on the computer vision part of AI because that's where my expertise lies. That's where my passion lies, and that's what I've been doing for the last decade. But AI, the AI stack, if you could call it that, is broad. It's huge, and it's growing. You saw Dan talk in the last talk about, just wait, what's coming in the Azure portal. Well, those guys in Azure go so fast, I can't keep up with them. I assume it's even tricky for Rick and Magnus to keep up with those guys. They go so fast. And of course, if you know me, if you've seen me speak before, I can't just talk to slides, especially if I can't see you and your reaction. So I'll do 3 pretty compelling demos here. All right, let me plow through the obligatory about Tim Huckaby stuff quickly. You most likely don't know my name or the companies I founded. One of the reasons is because we built software for other companies for over close to 30 years. And because of that, unfortunately, most of the work we do is covered by NDA, very strict NDA. So I cannot talk about what we did in detail for most projects. We've built some really high-tech software for other companies. And I've been involved in doing this for almost 25 years. The client list is impressive, spanning a good portion of the Fortune 1000. Here's a smattering of the ones I can mention, and they're grouped kind of sort of by industry. What we've done for most of these companies is way off limits to discuss. Being that said, we will discuss some really interesting stuff. Hello, slide deck. Why are you not moving? Oh, this is awesome. I have PowerPoint hung. There we go. PowerPoint's back. Wow. 30 years of Microsoft Office and PowerPoint still hangs. So here's a bunch of famous people using software we've built. We've been lucky to build a lot of software for broadcast television. We're 100 miles south of or I'm 100 miles south of Los Angeles, Hollywood, and 30 miles north of the Mexican border, if you're trying to figure out where I am. Anyways, a lot of broadcast TV is done in Los Angeles. You'll be familiar with this one. Everyone in the free world has seen this. This application is the ultimate in data visualization and content management. Over 250 million people at a time worldwide experience this piece of software during the United States presidential elections. Okay, let's jump in. From cancer research and detection to rare disease identification to machine learning on the human genome to COVID-19 detection and recognition, AI does save lives. It saves lives right now, and it's been saving lives for a year. I'm proud that I've been working in computer vision and 3D-based solutions for solving cancer and many other diseases and syndromes for over a decade. Oh, PowerPoint is giving me fits. Bear with me. We may have to do this differently if PowerPoint doesn't behave. Bear with me. Come on, PowerPoint. Oh, why is there always something? Okay, hang on here. Man, I am hung. Okay, let's, when you're hung, I'm a professional. Let's do a little demo here. How about that? There. Did I get it? Oh, sorry, guys. Bear with me. We're going to do this a little differently. I cannot get PowerPoint to advance.
Hey, man. This is not
yeah, sorry, my brilliantly awesome computer is totally hung.
It's okay. I mean, take it off and come back on again. That's we can talk for a bit.
I'm trying to kill PowerPoint. Hang on.
So while you're doing that, I can share with you that there's lots of stuff going on in global Azure at the moment, and I don't mean for people to go away, but did you notice that we have, there we go, on screen now, there's like 443 speakers. They're delivering 438 sessions, and they're all part of like at least 60 almost communities across 6 continents for this event. And that is a pretty impressive number, considering that we're still, by and large, in a pandemic right now, which is terrible. Considering, but we are coming towards the end of that pandemic, and having these numbers during a pandemic just shows you how many people are interested in learning about technology and about the cloud and about Azure, right? Tim?
True that. All right, I'm back.
Yes.
I don't know what PowerPoint's deal is. So here, and this is ironic that you mentioned the pandemic. So early in the pandemic, we built software actually to identify COVID in X-rays, COVID-19. I can't do this demo because HIPAA's involved and blah 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 la 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 la. But you can do it. The URL's in the slide, and again, you can download my slides at the end. This is another one of those projects of ethics I'm proud of. It's work done with the very same Microsoft Custom Vision API to recognize that I'm going to show you how to use later in this presentation. This research and proof of concept was published by a bunch of brilliant doctors and scientists. Oh, I don't know, a year and a half ago. And since it was the first in the space race to recognize COVID in X-rays, it got a ton of attention. Now check this out. This is the work we did for an ISV in face detection, not facial recognition, face detection, meaning we want to use artificial intelligence to identify all the faces in a frame of video. We called it the multi-scale face detector or something like that. If you think this through, it's a bit staggering. Remember that HD video is simply 30 pictures. We call pictures frames. So HD video is just 30 frames put together per second, 30 frames per second. I still haven't seen anything better than this for face detection. Even in Windows, Windows is not designed to look at multiple faces. It's just designed to grab the one that's in front of the computer to authenticate you. In this example, it's literally identified hundreds, if not thousands, of faces in one single picture. Now, It's not processing the face in any way. It's just detecting them. It's not doing the facial recognition or a demographic profile on the faces or anything like that. If you wanted to detect, then process each face identified in this frame of video with a trained AI algorithm and do it in real time, you'd need one heck of a powerful computer. But that's the type of power we're getting in our CPUs. And I'll talk in detail about that in a minute. And you need to do this in real time, practically at the speed of the camera. Face detection is the hard part, believe it or not. Face identification, frequently called facial recognition, is a solved problem. It has been solved for years. Oh my God, PowerPoint is just killing me. Oh, you know what? I could use touch. I'm a tactile reinforcement guy. Let me just use touch from here on in. Maybe it's my mouse that's killing me. Hey, what is fairly new to compute power that translates into machine learned models with accuracy? Let me explain that. Uh, uh, oh, this is interesting. I'm still having problems with PowerPoint. Okay, I got it. Wow, computer misbehaving today. So this is NIST, the National Institute for Standard Technology. Every 4 years, for the last many years, NIST has done a standardized testing on facial recognition algorithms. They do a lot more than that. This is a standardization group, very impressive group. The latest results were in 2018, 2019. That means they have one coming up this year, a new one. It's pretty exciting for a guy like me. And they include hundreds of facial recognition vendors. At least they did back in 2019. Let me talk you through interpreting the two of these results. I've pasted into the slide from the latest NIST testing. On the top is absolute accuracy. And look who won. Microsoft. For the first time in history, understand that NEC has dominated this testing forever. You're staring at 99.94, 99.81, and 99.73% accuracy in person identification and facial recognition. On the bottom is the gains in facial recognition accuracy since 2013. I mentioned NEC has won this thing forever. Well, since 2013, we pretty much jumped from 96 to 97% accuracy, which is pretty darn good, to 99% accuracy in facial identification. All righty, time for a demo. Let's see if PowerPoint will let me go. All right, I think I might have fixed PowerPoint, or it fixed itself. Let's do a demo. And that is here. All right, this is the Microsoft Intelligent Kiosk. I'm using the compiled version. I could just as easily run this out of Visual Studio, but talk about waiting. It's a beast of an application. As you saw a minute ago, this has a ton of demos in it. So yes, the source code is available and the link to it is in my slides. Let's see, I need to get back to there it is, the streaming technology, so that I can stop my webcam. There we go. So you no longer are seeing me. Perfect. My camera went off. Now let me do this. Magnus, you're going to have to tell me if you guys can see this. Oh no, the streaming technology has not let go of my camera. Nothing but technical problems here today. Okay. I'm gonna kill this and then I'm gonna start it again. Windows, actually Linux, all modern operating systems cannot handle sharing the camera. So that means I have, from the streaming technology we're using today, I have to turn off the camera and then I have to turn it back on so that my application can use it. But Magnus, I'm waiting for ideas here that this streaming technology is not letting go of my camera. Yeah, this is not happening. Darn it. I have a bunch of computer vision videos and I need to use the camera.
Okay. That I don't know, because if you stop your cam, which you have right now,
I
right?
could stop. I did stop cam, but I can see it hasn't let go of it yet.
Okay.
I could stop sharing and come back really quickly.
So tell you what we're going to do. We're going to remove you from the stream and put you back in again just very quickly.
Okay. I'll stop sharing then too.
And you're back, Tim?
Yeah, it hasn't let go of my camera.
So it's still using your camera. Okie dokie. Then
I could kill this. I could kill this. You know, it might be IE. I could quit this and then come back on come back again, if that's okay.
So your friendly neighborhood producer is joining to be helpful here. I think, Tim, the issue is that so StreamYard's running in your browser, right? You joined the call. You said yes, you wanted to be able to use your camera. Just because you're turning it on and off inside this call doesn't mean it's letting go of the camera for your demo.
That's right.
I think Magnus is right. The only way to actually give it up is to close the browser tab, but that means you leave the call.
Okay, I could leave the call and jump right back in.
Give it a go if you like. Yeah.
But then in that case, Tim, do not activate your camera at all.
Yeah, that's a good idea. Okay.
Do it.
Beautiful. I'll be back.
We'll be right there. Rick and I will riff. So we will riff in the meantime.
Yes. So, hey, Magnus, I wasn't expecting to be on camera today, but okay. How you doing?
Wonderful. I'm doing great. Thank you. So
I said, Tim says he'll be absolutely fine. He's a seasoned pro. He's done this before. Of all the ones we're going to worry about, Tim's is going to be the last of it, right?
Well, the issue is, of course, like you say, and what Tim was saying as well, right? That Windows cannot share the camera.
Yeah.
And that is a severe limitation in scenarios like this. You cannot be on a call like this and show something from your camera in a different app.
Yeah. Unless you've got more than one camera connected, right?
Then you need to have more than one camera. Yeah.
And we've all got laptops. How many of us have got lots and lots of webcams connected?
Yeah, that could be the thing that we tell Tim when he comes back. If he has multiple cameras, then maybe he can join with a different laptop or something like that.
Indeed. So anyway, let's talk Global Azure for a few minutes while Tim sorts himself out. So you mentioned communities around the world. Let's give a shout out to David. Actually, he's one of the organizers, because I think he was in Barcelona yesterday, wasn't he, for a live stream, and he's organizing a live event as well in Madrid, isn't he? That the Global Azure Spain are doing 2 events this year.
And yes, they are. And what we see from some of these, not English languages, right? So vast majority of our content is in English language across the globe, because that is our common technology language. But for people who are Spanish speaking or German speaking, they're not always, super happy about using English for everything when they got great languages of their own. And what I love to see in here in Global Azure is that we have so much solid content from big community organizations, such as the Spanish one and the German one. That's the reason I brought those up, because I know that we have, pretty good coverage in German and in Spanish. And it's pretty impressive, I think, to see that these communities are everywhere. It's not only about English.
No. So on our session picker, if you look, you can filter by language. There are 14 different languages that speakers have submitted content in this year, and you can filter that down to your language of choice. And you can also, if you expand the communities tab there. So we've got communities on our map. They're the ones that are organizing events. And their sessions are plugged into our agenda, right? And their pennies on the map, because some of them are in person. Yay, in person. But some of our individual contributors are also associated with communities. Like Magnus, you run a user group, I think, in Malmo. You're involved with the scanner group. Yeah.
Yeah, the Azure Skona, which is our region. Yeah.
Yeah. So those speakers have put those communities in there as well. So you can see, literally, I think we've got a good 100 or so, more than 100 speakers representing their communities. And that looks like we have a Tim back. So
we do have Tim back, and we're going to give control back to Tim.
You can hear me, right, guys?
We can hear you, sir.
I'm back, but StreamYard will not let go of my camera.
Wow.
It's configured to grab the camera. And here we did a tech check yesterday. So I'm going to have to talk through a couple demos.
No worries.
Which is fine. And we'll be on time. I need to go faster.
That's okay, Tim. I'm going to be off screen again, so you can keep talking. Take it away.
All righty. So I just pimped this. Am I allowed to use that word? I just pimped this awesome demo. Am I sharing?
No, I shared my screen.
Yeah, I was screwing with. There we go. Now I'm sharing.
Yes, you are.
So I just pimped this awesome demo and told you can get this incredible source code because it does so much. So I'm just gonna have to quickly talk through what this does. I was gonna show you how good this application, which is called Intelligent Kiosk, does facial recognition, recognizes objects. I was gonna walk around my home office, even from way back where the door is, which is 20 feet, it can still recognize me on just this tiny picture. It can figure me out and recognize me. It also tracks the male-female thing, how old I am, and it does it with wild accuracy. And like the screenshot before, you put a number of people in this, and you're only limited by CPU cycles and network bandwidth, meaning this is an Azure demo or application. It's sending those frames up to the cloud, up to Azure to be processed, and the answer comes back. So this application actually does need some bandwidth, which leads to architectural discussions and issues with how you do these computer vision type demos. It does an emotional profile of me too, meaning happy, sad, anger. You can imagine that companies use this information where privacy law allows, and we'll talk about that too, to target advertising for you. So if you're in a grocery store and you're staring at a product and you're happy, or you're showing disdain or something, that actually affects targeted advertising. I'm ashamed to admit that I designed that particular piece of software, and there are companies using that kind of for bad. So let's keep going here, and hopefully we won't have any more technical issues. And then you could run that demo yourself. You'll be shocked at how good it is. Would you feel like your privacy law was invaded if you were analyzed by computer vision in public places, like I just talked about, like in retail in the middle? Would you be uncomfortable if the system knew that every Saturday at the grocery store you bought ice cream? Some people would be very uncomfortable with that. The retailer wouldn't know who you are. You would have a unique GUID or identifier. They would just know that every Saturday you're there and you buy that. In loyalty scenarios, they may know who you are. You may opt in, knowing or not knowing, to be recognized in retail, right? In the government, there are very few places in the world where there is no privacy law. Obviously, in Asia, and then a lot of Latin America. And people are very uncomfortable to have governmental entities looking at you. Now, they argue that they're looking for the bad guy, and they are. Let's face it. That, terrorism is real. They're looking for terrorists. But in many places, I can speak for privacy law around the world, but I'll just speak for the U.S. because we seem to be the most screwed up about it. We have federal privacy law, meaning at a United States level, and then we have state privacy law, meaning I'm in the state of California. It has its own privacy law that is often, I can tell you right now, it is in conflict with federal privacy law. And then because California is so screwed up, we also have civic-based or city-based privacy law. The city of San Francisco has privacy law that accidentally is so strict that they're making it an unsafe place, meaning they've taken the tools for the police and authorities away to identify bad guys. I shouldn't say it out loud, really, but if you were a bad guy, that's the city you would attack. It's really a shame. I'm sure they'll fix it soon. All right, enough about that. That's the ethical thing. So how did all this AI thing happen? Sure, there were significant achievements in software. I mean, machine learning is on this huge curve of productivity for the last, 10 years. But really, this revolution came about, frankly and simply, because our CPUs just got more powerful, ridiculously powerful. And they continue to at a shocking pace. This is Dr. Gordon Moore, founder of Intel, one of my personal heroes. I've never met him. He's still with us. He's way up there. He's got to be over 90 by now. I'd love to meet this guy. It's not likely. He made a law, was a prediction, an uncanny prediction that has continued to be accurate for 58 years. He wrote an article in, I believe it was Popular Mechanics magazine, way back in 1965, and he noticed that we, as a technology world, had been doubling the amount of circuits we could install on a circuit board every 2 years, and that doubling had continued for almost 8 years. Well, this trend that he noticed, and by the way, this is when he was working for a camera company. This is way before he founded Intel. He noticed that it was the amount of circuits on the circuit boards were doubling every year. He later refined that to every 2 years. And the reason this is important is because Moore's law is still on track, and because software ultimately reflects hardware. So check this out. There's Moore's law as mapped transistor count on the Y and then years on the X-axis. And I can't wait to get an updated version of this, because the last 2 years have been super interesting in terms of CPUs by a number of vendors, not just Intel, right? On the top left, that number is 50 trillion transistors crammed on the current Intel, the current gen Intel CPU, 50 trillion transistors. Okay, now this is super interesting. Here's Moore's law as mapped against the calculation speed of the brain. Top right, notice our current CPUs calculate at the speed of the brain of small mammals like rabbits, rodents, things like that. Top right, also notice that if Moore's law continues to execute, our CPUs will calculate at the speed of the human brain by 2025. It's 2022. Get your arms around that. That top left number, in case you didn't notice, that's 100 trillion calculations per second. Get your arms around that. Our CPUs in just 3 years, if Moore's law continues to execute like it has for the last 60 years, and there's no indication it won't, will calculate at 100 trillion calculations per second. Does this mean computers will be smarter than humans and the machines are taking over the world? No. It's just a prediction, a very likely prediction, that machines will be able to compute as quickly as the human brain. But what does that really mean? Here's another demo that I can't do because this streaming technology is taking hold of my camera and I can't do a computer vision demo for you. But here's another one, links in it so you can run it yourself and the source code of how to do this. But the point here in this demo, and I'm using this guy swimming in his example, and you can see the results are a person swimming in a pool, which is pretty impressive. I was going to throw a bunch of pictures at you, including some live pictures of me in my home office, and show you how good it does and how poorly it does in some scenarios at describing what is in an environment, what's in the picture. Ultimately, I always say on stage, ultimately, we're going to make with computer vision technology and machine learning, we're going to be able to make a blind man see. And what does that mean? That means a blind man would wear glasses, and computer vision would be powerful enough. It is not right now, not even close, to describe everything around him. All right. Forget about the UI here. I mean, how in the world, the problem, of course, would be if machine learning could describe everything in front of a blind man, how would you get that information back to the brain? This is one of the very most intricate and not understood and amazing things in the human anatomy, the relationship between the eyes and the human brain and how quickly we can consume information. So forget about the UI. But by 2025, when we can do 100 million, what was that? 100 trillion calculations per second. Technically, you could describe everything in a frame of video and do it in real time. That's super powerful. And well, we'll get to how that could be good and bad here in a second. All right, so ethical violations. These are not new. These have been going on forever. To put some of the issues of AI in terms of privacy violations in context, realize these happened a decade ago. You have no idea, or maybe you do, what type of ethical violations are happening right now. A decade ago, Target did this brilliant machine learning project. Target is, if you're from Europe or another continent, Target is a US-based retailer, much like Walmart, if you know what Walmart is. They use machine learning to identify and then target advertising, physical advertising, like send you stuff in the mail towards pregnant customers. So they would recognize when a female was pregnant and then target advertising. A decade ago, it's famous that Apple put their secret tracking file on the phone so they could spam advertisements at you. They got caught red-handed doing that and paid gazillions of dollars of fine. Google, Facebook, many of these others created billion-dollar businesses on the unauthorized tracking of your web use, and they still do it. Amazon overcame the browser. This is one of my favorites. Flash. Flash had huge security holes in it, and Amazon exposed them and put a tracking piece of code in Flash so they could track you. And get that all of this is over a decade ago. Let's explore privacy a little bit further. Understand, you guys out there are the technology elite. None of this is probably news to you. But you only represent a tiny portion of the world who is completely blind to this stuff. My wife, completely blind to this stuff. There is a company who is an email provider that begins with a G in the Silicon Valley that most people are confident are using AI to scan the content of the emails going back and forth so that the advertising can be targeted at you when you get to a browser. You've seen that weird thing happen. Like, how in the world did they know I was interested in that fly fishing rod? That would be in my case because I'm a fly fishing. You've seen that weird type of stuff. How did they know that? It's because they're using really advanced AI. Your phone has a number of components to it that make it unique, which makes it really easy to do device IDs and fingerprinting. I think it's fascinating. In Europe, people tend to be a lot more privacy aware than they are in the US. We're kind of naive to this stuff, and that's why Amazon gives away an Alexa almost for free. Even we have an Alexa. Well, it's always listening. That's one of those Google Home like devices where it's listening to you and you say, Alexa, turn my TV on. Well, Alexa has this beautiful interface because a lot of really brilliant ex-Microsoft people are working on Alexa. And within 10 minutes, I had trained Alexa to recognize my wife's dog barking. And the minute it's a puppy, and the minute it starts uncontrollably barking, Alexa says, Luna, that's the dog's name, is barking uncontrollably again. I did that in like 15 minutes. It's always listening. You can imagine if you're a retailer, how valuable it would be to listen to what, I don't know, you'd love to have but don't have the money for, right? Smart TVs, they're not only listening to you, but who was it that there's a major TV retailer that got caught actually looking at you too, which is crazy awful. All right, I can do this demo, thank God. This will be first time in a long time that I've only done one demo at in a keynote or technical presentation. Okay, here we go. This is believe it or not, this is part of the Azure portal, but it has its own unique URL called customvision.ai. This is the most poorly I think one of the most poorly named products in Microsoft. It's also one of the most powerful and awesome ones. Really, this should be called object identification and recognition, not custom vision. Object. So the next frontier, as I've alluded to, of computer vision is not recognizing humans or faces. So that problem's been solved. Body tracking, social distancing for COVID. That's all solved problems, really easy to implement. The next generation of applications will be recognizing objects. And that means, pointing your cell phone at a bird and having it tell you, what type of bird it is. But it also is, making a blind man see type stuff. So anyways, I've made this project, what was this, I don't know, last week before, called Sodas. What's important here is historically in the machine learning world, and frankly, it's still kind of true, you have to train, hundreds of thousands of images. Notice that I've basically trained around 30 images of Coke cans and bottles and Pepsi cans and bottles. Okay. And I'll show you it and the reason I only use 30 is two reasons. Number one, to show how awesomely powerful this tech is, because it's going to do an amazing job when I recognize a Coke or a Pepsi here in a minute. But then every picture, I have to trace a bounding box around, what's in the picture and then apply a tag to it. Make sense? So in this picture, that's the Coke. And in machine learning or in computer vision, images like this are not as powerful as images like this, because you want backgrounds and things like that. Because in machine learning for computer vision, what is not a Coke is almost as equally important as what is a Coke. Anyways, you give it a whole bunch of these pictures and you tag them, and then you just say go. I'm not going to do it here because what's going to happen is those wildly powerful computers that sit in these Azure data centers are going to crunch this and create the machine learning algorithm to recognize Cokes and Pepsis in about 60 seconds. I mean, there's some parameters you can throw at it, and it's configurable and things like that. And you could let it go for 2 hours if you want, and pay for that, obviously. But you don't want to stare at this thing crunch because I already crunched it for you. You want to see it in action. So I'm going to move over here to the performance tab, and this is fairly interesting because what it's telling us with that map metric, this green one, is that it's basically saying we're 86.4% effective with this particular machine learning algorithm that identifies Cokes and Pepsis. It could be better. You could get it close to 100% if I had more pictures of people holding Cokes or Cokes with different backgrounds or things like that. That's important. Precision means something like, well, 7 out of 10 times we were right, meaning 70%, 70.6%. Recall is if I have 15 Cokes and Pepsis and we recognize 10 of them, then we have, that's about 65%, I think. In this case, it's 85%. So it's, if I have 12 Pepsis and we recognize 10 of them, that's 85.7% recall. Okay, makes sense? Now, predictions. This is where you manage your pictures, meaning you continue refining the bounding boxes and you train the thing and it comes up with errors and you get new pictures and you do that here. I'm not going to do that here. But the endpoint is what you'd use in your application. This is just a REST API. This is super simple to put into production. Now you may be thinking, well, how much does this cost? This is free for developers, just like almost everything in the Microsoft world. Free for developers. If you put it in production, last time I looked at pricing, it was $1.60 per 1,000 transactions. Think that through. $1.60 US per 1,000 transactions, which sounds ridiculously cheap. But if you think it through, and we've been bit by this before, or I've been bit by this before, if you have thousands of cameras at an event and they're doing 30 frames a second, if you add that all up and they're going 24/7, that adds up quickly. That adds up to hundreds of thousands of dollars per month. So your developers have to be careful in how you use this thing. But the point here is it's so simple to implement this REST API. So I'm not going to use my camera here. I'll use a static image and just pretend like it's a camera. That's why we could do this demo here, even though the streaming software has got my camera. So we'll go at local files. Oh, I was practicing yesterday. So I like this one because it's an occluded picture. I don't know if you could see that because it's so small, but it's a Coke can with a polar bear on it, and it's sideways. So it's going to do its crunching, and check that out. It said with 98.8% confidence that's a Coke can. I failed to mention this to you. Everything in computer vision comes with a confidence. There's no 100%. If it recognizes Tim Huckaby, like the demo I wanted to give to you, it would be about 98, 99% confident it's Tim Huckaby. All right, let's just do another one real quickly, and then we'll move on to something else. Let's do one. Oh, do I have? There's a tough picture. We should have less confidence on this. Yeah. Oh wait, we need to do here. That's pretty darn good. Considering everything in this picture. Now, it would be more impressive if this was a real background, not a white background. But it's saying I'm 87.8% confident that guy's holding a Coke can. That's pretty darn good. That's amazing. Again, this is just a REST API. Even I can implement a REST API, right? This is free for the developer. You could build an application in like 20 minutes with this tech to recognize when your kid comes home from school with the camera you have on your front door, or something else like that. All right, let's get rolling here. We've got 12 minutes to plow through this stuff. All right, you want to know what scares me the most? Deep fakes. You guys know what deep fakes are? That's another oddly named thing. This is basically creating virtual humans. I have Carrie Fisher here from Star Wars because, excuse me, still early here. Had to take a drink of coffee. In the last Star Wars movie, they filmed it with Carrie Fisher in it as Princess Leia long after she had passed away. they they did a deep fake and created her synthetically. Many people speculate that in Hollywood, we're not going to use highly trained actors in a decade from now, maybe even shorter than that. Why pay a beautiful, highly trained actor when you can make perfect human actors and have them be so real? So that's powerful, right? The problem is any 12-year-old can use this technology to simulate your voice and call your grandma and say, I need $20,000 immediately, and I need you to wire it to this account. And your grandma, in a virtual piece of software in AI, would interact and talk back and forth, and you'd be convinced. Even I could be fooled by something like that, unless I started firing questions at it that it would overcome. Really, is this you, grandma? What was your husband's name? That type of thing. That's scary. Deep fakes and the potential for bad people to do bad things is real. It's significant. And honestly, I don't know how we're gonna get over it, but we're gonna need to. All right. This is even more scary. This is unfortunately a part of our world, and this is not just a US thing. This is an international thing. There are crazy people all over the world. And it's just, when I watch the news, or Kelly and I watch the news each night, it just seems like every night or once a week there's some horrible random shooting. And let me tell you this, we're using AI to help. This project, I designed and built this machine learning model to recognize weapons in real time. So I'm proud of it. And it was not easy, and it's not perfect. And I can't do this demo because I don't own a gun. But here in Southern California, only bad guys own guns because we don't have hunting or anything like that. This is a beach town. But imagine a world where a weapon is recognized by computers in a crowd immediately and sends alerts to the authorities. Imagine, this running on 20-year-old surveillance cameras in a local grammar school. And the minute the knucklehead, this crazy guy, drives on the school property, opens his trunk, that camera catches it and alerts it. In this world, they say every second counts. Well, if you save 10 seconds in recognizing a weapon, you could save a ton of lives. Here it is in action. And I don't know if you can see the resolution of that, but over that bounding box, it's saying, shoot, I can't even see the resolution of that. It's saying it's a rifle, and I'm 87% confident that's a rifle. And then here's an example of an alert it sent. This is a lot easier to read. I'm 90% confident that that's a pistol. By the way, see the red tip? That's my buddy Tony. The red tip on any gun means it's a toy. I don't know if that's a worldwide standard, but that's a US standard, to help the police from shooting people who are holding toy guns, right? Makes total sense. All right, so let's wrap this up. I'm gonna make it, guys. As technologists, we have this ethical responsibility to push AI to places where it helps the world. I don't know if you've read these two famous books. They're quite good. They're quite interesting. Orwell and Huxley, they portray this dystopian view of the future of the world, this awful view of the world run by machines. I don't see it like that. AI has the power to be Big Brother, but it also has the power to save lives. Like any technology, us developers and us technologists have a duty to be responsible. We have a duty to spread the awareness of the ethics of AI. I cannot tell you probably the handful of times that I've built something that other companies have used for bad. And that's a bummer. Okay, so is AI or computer vision, is this a weapon or a lifesaver? I like this slide. I like to compare it to nuclear power. With nuclear power, we got the freaking microwave. How could you live without a microwave oven? We also have very efficient engines, propulsion for ships, submarines, etc. We have very efficient and inexpensive energy. But its byproducts are lethal to millions. And it also creates the world's most efficient weapon, which is being threatened in today's society. I can't believe in 2022 we are considering having to defend against nuclear weapons, but we are. AI, on the other side, it saves lives. It makes life easier. It automates menial tasks. That's kind of the bold promise of machine learning. The stuff that, a human would just rather die than do because it's so menial, it does that for us. And it entertains us, like in the case of Carrie Fisher in Star Wars. But the negative side is it replaces low-skilled labor. And more significantly, it's a tool for bad guys to take your money and commit fraud. And it's a tool for bad companies and bad governments to track you and invade your privacy. All right, let's wrap this up. In summary, with the great power of AI comes responsibility. And I'm talking to you developers. Machine learning is on this growth curve like a hockey stick in terms of performance and precision. There are many world-changing use cases for the good, and there's some bad ones too. Computer vision is powerful and it's easy to implement. The source code is out there to make this really easy. I mentioned the recognition of objects, and we're just in the infancy of this. But if you are into animals and you wanted to build a machine learning algorithm for your phone that recognizes, the animals in your wilderness, that is so doable right now. And as Moore's law execute and our CPUs become powerful, and frankly, our batteries keep up in our mobile phones, that's the big draw on the CPU, the battery. Battery tech has to keep up with our CPU power. Then you'll be able to do this type of stuff. Okay. I hope, barring all those technical problems, it's been a long time since I had so many technical problems. I hope you enjoyed that. If you want my deck, you can download it right here. And then if you want to contact me, there's my stuff. But that's it. That's all I got. Magnus?
Yes, sir. I'm back. Well, you can turn on your camera now again, I guess, so we can see each other.
My view of this is I'm seeing my camera as being on. So
Okay.
all right, let me turn it back on. I have to remember what browser I put it in. Hang on here.
That's okay.
While I do that, any questions or comments?
Well, I mean, the comments are that this stuff is mind blowing. I was just saying here on the chat behind the scenes that seriously, this Moore's law stuff, it is uncanny.
Oh, it's awesome.
Yeah.
I've been working with Intel for excuse my language. I don't know, 7-8 years now directly. Yeah. And they have a computer vision technology, by the way, that runs on the edge. I showed you cloud-based, Microsoft's tech is cloud-based. They have it running on the CPU edge. It's called OpenVINO. I've done a number of projects in OpenVINO. But I get to sit in meetings where they talk about product planning, and it's like, what do you do with that CPU power? So normally, how are we doing? We got 3 minutes?
Yeah.
Normally, the question I get when I do this keynote or talk is, Tim, what do you think about quantum computing as it relates to this?
You're giving your own questions now. That's cool.
Well, I assume there's no question, so I can provide my own question.
Good.
And because we only had, an hour 45 minutes, I didn't put a slide up for quantum computing. I'll tell you right off, I am no expert at quantum computing. Right. I'm studying it. And frankly, it may be beyond me. It might be too much for me.
Maybe.
But in reality, it's hard for me to grasp that a 1 can change into a 0 or a 1 can change into a half. That's quantum computing, right? So in quantum computing tackles some methodical algorithms fairly easily. The famous one, of course, is it's going to break all our encryption, within, what is it, a couple of years. That has to do with CPU power, by the way. So all our encryption, the whole blockchain thing, the whole cryptocurrency, it falls apart unless we figure out how to overcome quantum. That's the reality. They're smart.
And we will. I'm sure we will.
And the human genome, it can map the human genome. Now, I haven't seen a lot yet with applying artificial intelligence to quantum computing.
Yeah. And I'd love to just keep talking with you all week long. And we're at the end of our live broadcast because Learn TV is going to kick us out. So
yeah, perfect. I got 30 seconds. So totally fun. See you in a couple weeks, buddy. Sorry for the technical details, but live and learn.
Thank you for being with us today, Tim, and delivering your talk about this ethics dilemma we stand before. Thank you so much for being with us. And everyone else, go back to our website, globalazure.net, and please continue watching wonderful, wonderful presentations from so many people around the globe today, this evening, and tomorrow as well, depending on time zones where you are. We're out. This is it.